Let's take a look at a pesticide manufacturing plant in Bhopal, India. There is a storage tank used to store methyl isocyanate, known as MIC, which acts as an intermediate in the reaction to form the pesticide. MIC needs to be handled with care as it is extremely toxic. It should never be mixed or contaminated with water, as that will result in a highly exothermic reaction, producing harmful toxic gases. To deal with this, a manual safety valve was installed to prevent water from entering the tank during maintenance. Imagine if the manual safety valve corroded due to a long service time and malfunctioned. Because of this, water was able to flow into the storage tank, causing a highly exothermic runaway reaction with MIC. The refrigeration system that was supposed to regulate the temperature of the storage tank did not take into account the temperature rise due to the runaway reaction, as there is no control system to adjust the flow rate of the coolant. Therefore, the amount of coolant supplied will be insufficient to mitigate this unexpected rise in temperature. As the reaction proceeds over time, more toxic gas is produced and the pressure in the tank increases. Thus, the pressure relief valve was activated to release the toxic gas to a vent gas scrubber. However, the amount of toxic gas far exceeds the capacity of the vent gas scrubber. Hence, a large amount of MIC gas and the harmful products of the runaway reaction leaked into the atmosphere, creating a gas cloud containing chloroform, hydrogen chloride, dichloromethane, and carbon dioxide. As most of the components of the gas cloud are denser than air, the gas cloud remained close to the ground, spreading to villages nearby, resulting in the death of humans and animals. So, how could this have been mitigated? First, a feedback control system could have been implemented by installing a water analyzer, transmitter, and controller next to the manual safety valve. If water is detected in the pipeline entering the storage tank, a new gate valve will automatically be closed, preventing water from entering the MIC-filled tank. Next, a feedback control system could be added by installing a level transmitter to monitor the level of MIC in the tank. Once the level of MIC reaches the maximum amount in accordance with safety regulations, the transmitter will send a signal to the level controller, which will close the control valve at the inlet of the storage tank to prevent further flow of MIC into the tank. So if any undesired reactions were to occur, the implications would be less serious as the amount of MIC present will be lower. Moreover, a temperature control system can be installed to regulate the temperature in the storage tank. A temperature transmitter in the tank, which links to a temperature controller, can be connected to the control valve of the coolant. This allows the flow rate of coolant supplied in the refrigeration system to be manipulated. When the temperature of the storage tank increases, the controller would open the control valve to increase the flow rate of the coolant. This would reduce the amount of gas entering the vent gas scrubber and enable the toxic gas to be sufficiently neutralized. Finally, another feedback control system can be implemented in the vent gas scrubber by adding a flow sensor at its inlet. Upon detection of a high flow rate of gas entering, a control valve will be opened to increase the flow rate of the caustic scrubbing liquid. This will allow more toxic gas to be removed before being vented out to the atmosphere. The consequences of the gas leak could have been minimized if all these mitigation plans were executed at the same time. Before we end the video, let's compare the actual Bhopal disaster and our hypothetical incident in terms of the cause of the disaster and the confinement attempt. The actual Bhopal disaster was caused by operator negligence as they forgot to place a slip blind to prevent water from flowing into the MIC storage tank whilst conducting maintenance on a nearby process equipment. Also, both the refrigeration system and vent gas scrubber were switched off as the plant suffered financially and had to save on operational costs. In our hypothetical incident, the cause of the disaster was due to a faulty gate valve that corroded over time, allowing water into the tank. Besides, both the refrigeration system and vent gas scrubber were switched on, but they lacked any control measures. As for the confinement attempt, in the actual Bhopal disaster, operators tried to spray water at the exiting gas. However, due to improper sizing of the pump, it was not able to reach the top of the vent outlet. On the contrary, in our hypothetical incident, the confinement attempt had been made when the refrigeration system was switched on to cool the storage tank, but it failed to provide adequate cooling as the coolant flow rate was insufficient. Besides, the vent gas scrubber attempted to confine the toxic gas but was unable to remove enough MIC to a safe level as it lacked control of the caustic scrubbing liquid flow rate.